With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, this question contains 4 parts. In the first part, we have to arrange the compounds in the order of decreasing boiling points and in the order of decreasing solubility in water. In bit A, the compounds given: first ethanol, propane and pentanol. Ethanol is an alcohol. We can write CH3CH2OH. Propane is a alkane, that is CH3CH2CH3. Pentanol is a alcohol. We can write CH3CH2CH2CH2OH. Among these compounds, ethanol and pentanol are primary alcohols and contain OH groups. This OH group helps ethanol and pentanol to form hydrogen bonding. But in case of propane, there is no electronegative atom like oxygen, so it is a non-polar molecule. Propane is a non-polar molecule. So propane will have least boiling point. Due to hydrogen bonding in ethanol and pentanol, they need more temperature to break the bond. So in those cases, the boiling point is high. If we compare the boiling point of ethanol and pentanol, pentanol has more molecular weight than ethanol. So the boiling point of pentanol will be more than that of ethanol. So the order of decreasing boiling points here is 3 greater than 1 greater than 2. Now let's check the solubility in water of these compounds. We know water is a polar solvent. Polar substances are dissolved in polar solvent. Among these 3 compounds, propane is a non-polar molecule, so its solubility in water will be least. And ethanol and pentanol are polar compounds. The OH group of ethanol and pentanol will form hydrogen bond also with water, but the hydrocarbon tail will not form any hydrogen bond in water. Here ethanol has a short hydrocarbon group, but pentanol has a longer hydrocarbon group. These hydrocarbon groups are non-polar hydrocarbon group. Hence, pentanol will be less soluble as compared to ethanol in water. So, ethanol is more soluble in water than pentanol. Next, the compounds given are butane, 1,2,3-pentane triol and butyl alcohol. Butane is CH3CH2CH2CH3. Then pentane 1,2,3 triol, 1 position, 1 alcohol group. Here is one alcohol group and here is one alcohol group. Let's fill the valency of carbon. This carbon will join to one hydrogen. This carbon will join to one hydrogen. This will join to two hydrogen and this will join to three hydrogen because carbon has valency 4. Butyl alcohol CH3, CH2, CH2, CH2OH. This is a primary butyl alcohol. Butyl alcohol may be secondary and tertiary also. But in butyl alcohol, one OH group is present. And in pentane triol, 3 OH groups are present. And butane is a non-polar molecule. Due to 3 OH groups of 1, 2, 3 pentane triol, it will have more boiling point than butyl alcohol because in butyl alcohol one OH group is present. So 1, 2, 3 pentane triol will show high number of intermolecular hydrogen bonding than butyl alcohol. So what will be the order of decreasing boiling point? Compound 2 is greater than compound 2 is greater than compound 1. Now let's check order of decreasing solubility of these compounds in water. Butane will be least soluble because it is non-polar molecule and water is a polar molecule. Between 1, 2, 3 pentane triol and butyl alcohol, 1, 2, 3 pentane triol will more soluble because it has 3 OH groups. So it will form more hydrogen bonding than butyl alcohol, which contains one hydrogen, one OH group. So the order will be same to decreasing order of boiling points. In the third bit, the compounds given are pentane, pentanol, hexanol. Pentane is CH3, CH2, 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 CH3. For pentanol, we can write CH3, CH2, 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 OH. And for hexanol, we can write CH3, CH2, 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 CH2OH. Hexanol has 6 carbon. See here, pentane is non-polar molecule. So it will have least boiling point and least soluble in water. Among pentanol and hexanol, molecular weight of hexanol is more than that of pentanol. So, if we compare the boiling points, decreasing order of boiling points will be 3 greater than from 2 greater than from 1. This is due to pentanol and hexanol both show hydrogen bonding due to their OH group, but the molecular weight of hexanol is greater than molecular weight of pentanol. So hexanol will need higher temperature to break the bond. So it has a more boiling point. If we compare the solubility in water, pentane will be least soluble in water, and pentanol and hexanol are polar substances, but in pentanol there is a hydrocarbon chain with 5 carbons, and in hexanol there is a hydrocarbon chain with 6 carbons, and the hydrocarbon chain is a non-polar type. So pentanol will be more soluble than hexanol because pentanol has a non-polar hydrocarbon chain with less number of carbon atoms than hexanol. Next it is asked, arrange the following in the decreasing order of their boiling points. The compounds given here are C3H8, that is propane, C2H5OH, that is ethyl alcohol, CH3 2O, that is dimethyl ether, and the last one is ethanol or glycol. We have to find out the decreasing order of their boiling points. See here, propane is a non-polar molecule, so it will have least boiling point. Here 2, 3 and 4 compounds are polar, but in glycol there are 2 OH groups, and in ethyl alcohol 1 OH group, and dimethyl ether has no OH group. So dimethyl ether will not show hydrogen bonding, and glycol will show more hydrogen bonding than ethyl alcohol. So in case of glycol we have to give more temperature to break the bond. So glycol will have highest boiling point, then ethyl alcohol which has 1 OH group, then dimethyl ether which is a polar molecule but don't show hydrogen bonding. So this is the decreasing order of boiling points of these 4 compounds. Next, in the third part of the question it is asked, arrange the following alcohols in the decreasing order of their boiling points and in the decreasing order of their solubility in water. The alcohols given here are n-Butyl alcohol, secondary butyl alcohol and tertiary butyl alcohol. In normal butyl alcohol, OH group is attached to a primary carbon atom. So this is the structure of n-Butyl alcohol. In secondary butyl alcohol, alcohol is attached to a secondary carbon atom, that is the carbon which is attached to 2 alkyl groups. One is methyl and the other is ethyl, and to fill the valency of carbon, here it is hydrogen. In tertiary butyl alcohol, hydroxyl group is attached to a tertiary carbon atom which is attached with 3 methyl groups. This is the structure of tertiary butyl alcohol. Among these 3 compounds, more branching is seen in tertiary butyl alcohol, that is compound 3, and less branching is in normal butyl alcohol, that is a normal carbon chain. Due to more branches in tertiary butyl alcohol, it has less surface area. So what will happen here? In tertiary butyl alcohol, the van der Waals force of attraction will decrease. So that can be overcome at a relatively lower temperature than those compounds which have less branching and more surface area. So boiling point of tertiary butyl alcohol will be least. Boiling point of normal butyl alcohol will be high because of low branching and more surface area. Then boiling point of secondary butyl alcohol, which has more branching than normal butyl alcohol but less branching than tertiary butyl alcohol. So this is the decreasing order of boiling points in these compounds. Let's see decreasing order of solubility in water. See, in normal butyl alcohol, area of non-polar part is more, so it will be least soluble in water because water is a polar molecule. In secondary butyl alcohol, the area of non-polar part is more than that of normal butyl alcohol because it shows branching more than normal butyl alcohol. If you see tertiary butyl alcohol, here non-polar part has least surface area than these compounds due to more branching. Hence, the solubility of tertiary butyl alcohol is more than that of secondary butyl alcohol, that is more than from normal butyl alcohol. So we can write solubility of compound 3 is greater than from compound 2, greater than from compound 1. In the last part of the question, it is asked, arrange the following compounds in the order of increasing boiling points. The compounds given here are CH3COCl, CH3CO2O, CH3CONH2 and CH3COOH. That is acetyl chloride, acetic anhydride, acetamide and acetic acid. Among these compounds, acetic anhydride has highest molecular weight. So it may have highest boiling point. In 1, 3 and 4 compounds, only acetic acid, that is compound 4, shows hydrogen bonding. So here dimer-like structure is formed in case of acetic acid. But acetamide shows polymer-like structure. So among these compounds, acetamide will have highest boiling point, not acetic anhydride, due to capacity of forming polymers like structures. Acetamide overcome acetic anhydride in boiling point, though acetic anhydride has highest molecular weight here. So compound 3 will be highest boiling point. Between acetyl chloride and acetic acid shows hydrogen bonding, and there is no hydrogen bonding in case of acetyl chloride. So boiling point of acetic acid will be more than that of acetyl chloride. That is, compound 4 has more boiling point than compound 1, and this is the required increasing order of boiling points. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.